video is about finding the domain of rational expressions. A rational expression is just a polynomial divided by another polynomial. The domain for a division problem, which is what a rational function is any number that you can put into this without dividing by 0. And so since we divide with the denominator, we got to make sure that the denominator never equals 0. So that's what we look at when we're trying to find out the domain of a rational expression. So for number 1, we have f of x is equal to negative 4x divided by negative 2 plus x. So we have to make sure it doesn't divide by 0. So we look at the denominator only. And we say, well, when would negative 2 plus x equal to 0? We cannot let that happen. So we just solve this equation for x. And so we add 2 to both sides and we find out that x is equal to 2. That's when that would be. So we said that cannot happen. So every other real number is allowed into this function except for 2. How we write that in interval notation, the domain would be of f would be from negative infinity all the way to 2. Union with 2 to infinity. And so these parentheses mean as close as I can get to 2 without it equaling 2. That's what that means. If it were a bracket, that would mean that it can be equal to that value 2. This is something you can think of if you have the number line. So here's 0, here's maybe 0, and here's 2. There's like an open circle on 2. It means every value except 2, from negative infinity all the way up to the left side of 2, and then once we get on the right side of 2, all the way to positive infinity. Okay, we'll go a little bit quicker through the next few examples. Right here, g of x, what would be the domain of here? As long as the denominator, 2x plus 5, doesn't equal to 0, then we're okay. So solve for x, subtract 5, divide by 2. As long as we don't let that happen, we're in good shape. So the domain for this would be from negative infinity to negative 5 over 2, union with negative 5 over 2 to infinity. That's an interval notation. Okay, here, let's try this one. As long as we don't let r of x is 3 plus 2x divided by x cubed plus x squared minus 2x. As long as we don't let the denominator x cubed plus x squared minus 2x, as long as we don't let that equal to 0, we're okay. So set it equal to 0 and see what the values are that you need to exclude. I'm going to try to factor this. I'm going to pull out the greatest common factor, x, leaving me with x squared plus x minus 2. Let me see if I can factor this. You could use the AC method or trial and error, some method to factor this. Let's see, I think you could factor this into x plus 2 minus 1. Let's see. X squared minus x plus 2 would give me plus x minus 2. Okay, this is factored. Now I'm solving it. This will be true by the zero product property. Whenever x is equal to 0, x is equal to 1, or x is equal to negative 2. So we find that there are 3 values we have to exclude here. So if you have a number line, here is 0. Here is negative 2, and here is 1. We got to hop over all 3 of these guys. So that means we would say from the domain of R would be from negative infinity to the left side of negative 2. The right side of negative 2 to 0, to the left side of 0. The right side of 0 to 1. Oh my goodness, can you still see this? Good. The right side of 1 to infinity. All of that is the domain for this guy. Over here, this one won't be quite as bad. 5 divided by this, we don't divide with the numerator. Don't worry about the numerator. Notice I don't even look at the numerator in any of these when I'm trying to find out the domain. I'm only worried about the denominator. Right here, the denominator, x squared minus 7x. When would it equal to 0? Factor out of x. Set each one equal to 0. This is true when either x is 0 or x minus 7 is 0. So x is equal to 0 or x is equal to 7. As long as x does not equal to those 2 values, we're in good shape for the domain. So the domain of this R is from negative infinity to 0, union with 0 to 7, union with 7 to infinity. You could think of it, if you drew a number line, you just have to hop over those two values, but everything in between these guys is just fine.